Welcome back to Chapter 1.3, Part 2 of 11. In Part 1, we split the estimator, the random rule, from the estimate, the single number it returns. Now, we widen the lens. The sample mean is only one of many possible recipes. We meet its rivals, name the three words we judge recipes by, and define the first of those, bias. A notation convention we hold for the rest of the book: when we name an estimator as a rule, we write mu hat, an estimator of mu. The sample mean is one specific estimator of the population mean, so mu hat equals x bar here. But it is not the only estimator of mu. Priya could instead use the median of the 200 claims, or the mid-range, the average of just the smallest and largest claim, or the constant 7,500, no matter what the data say. Yes, that is a legal estimator, a stupid one, but legal, or a trimmed mean that throws out the top and bottom 5% before averaging. Each of these is a different recipe, a different random variable, with a different distribution. The job of this chapter, and really of the whole field of econometrics, is to develop language for saying which recipes are good and why. That language has exactly three words: bias, variance, and, combining them, mean squared error. Take the first word, bias. Run Priya's recipe not once, but, in your imagination, infinitely many times. Every possible 200 claim sample the universe could have handed her, each weighted by how likely it is. Each sample produces an estimate. Those estimates form a distribution. The question of bias is simply, where is that distribution centered? We say an estimator mu hat is unbiased for mu if the expectation of mu hat equals mu. On average, across all possible samples, it lands exactly on the truth. Its bias is the expectation of mu hat minus mu. Now be careful. Bias is not the error in your particular sample. Priya's 8,410 might be off from the true mu by hundreds of dollars. That is sampling error, and every estimate has it. Bias is about the center of the recipe. If you average the errors over all conceivable samples, do they cancel to zero, or is the recipe systematically aiming high or low? To summarize Part 2, the sample mean is only one estimator among many: the median, the mid-range, the trimmed mean, even the stubborn constant. We score every recipe with three words: bias, variance, and mean squared error. Bias, the first, asks where the recipe is centered across all possible samples. Unbiased means the expectation of the estimator equals the true mean, and it is not the same thing as the error in any one sample. In Part 3, we put the sample mean to the test, prove it is unbiased for any sample size, and then meet a recipe that quietly aims low.